I'm your math guy, Steve. Let's work on our factoring. So, when factoring polynomial functions such as this, we definitely want to use all the tools that we have. As far as if it's a quadratic, we know we can factor using the AC method, or factor by grouping, or even just double bubble, right? And so, whereas if it's a cubic or higher, then the way we factor these is by using the rational zeros theorem, or just any tools that we have in order to factor out the GCF. Whereas here they give us, so it says factor each and find all the zeros. So we'll do that, okay? And then 1 0 has been given. So they give us a 0 for this one. Okay, so they give us a 0, which means in essence we are given a factor. Okay, so how we find that is by saying, okay, well, we know that if 3 is a 0, then x minus that number is a factor. Meaning, we can factor this by saying it's x minus 3 times something. Okay, now how we find the something is by noting, okay, if I divide x minus 3 into this, the remainder is 0. All right, now we can divide this by either using long division, which takes a while, hence the name long, it's long division, okay, or synthetic division. So synthetic division will tell us, well, we put that number 3, put it in the corner, and then outside we put these coefficients, so 3, 4, negative 35, and negative 12. Again, the remainder should be 0. And in synthetic division, our steps are to first bring down the first number, and then it's just about to multiplying and adding. We kind of go in this zigzag, kind of zipper shape, okay, or pattern. So let's multiply by the number in the corner. 3 times 3 is 9. Then we add. 4 plus 9, 13. Multiply 3 times 13, we get 39. We add negative 35 plus 39 is 4. Multiply 3 times 4 is 12. We add and notice what we get. 0. So there's our remainder. Our remainder is 0, which we said that would happen if this is indeed a 0 of the function. Okay. So the remaining parts, the parts that are inside this next bubble, will be the 3. So this was a 3x cubed, so it goes down 1 degree. In other words, this is 3. This 3 is 3x squared. This 13, so plus 13x. And then this 4, so plus 4. Okay, got it. And so now we need to factor this further. So now we're worried about factoring this 3x squared plus 13x plus 4. So let's try it, okay? To factor that, so 3x squared plus 13x plus 4. To factor that part, we'd say, well, since it's a quadratic, if there's a 1 in front, we go straight to that double bubble. Okay, whereas if there's not a 1 in front, we try the AC method. The AC method says multiply A times C, so 3 times 4, we get 12. Okay. And what number is multiplied to give me 12? That combined to give me the middle, combined to give me 13. So in this case, 1 and 12. And so we'll rewrite this middle term as, so 3x squared plus 1x plus 12x plus 4. So it's rewriting that middle term using factors of AC. And now, instead of 3 terms, we have 4 terms. To factor 4 terms, we use grouping. Okay, so group these first two. What's their GCF? What do they have in common? Well, they both have an x in common, so we'll take an x off of each. If I take an x out of each, what's left? 3x plus 1. Okay. Now group these next two. What's their GCF? What do they have in common? Right? Well, they have a 4 in common. So I take a plus 4 out of each. What's left? 3x plus 1. And looky, they both got a 3x plus 1 in common. So we can take a 3x plus 1 off of each. Pull that off. So if I take a 3x plus 1 out of each, what's left is just those parts in front, that x plus 4. Okay, that x plus 4. So 3x plus 1 times x plus 4 would be the factored form of that. All right. So if we want to finish factoring this, let's try it. All right, so our factored form would be, we rewrite this as, so we said again, 3 was given, so x minus 3 times that 3x plus 1 times that x minus 4. Okay, so that would be our factored form. But it also says, and find the zeros. Now they're called zeros because if I set the function equal to 0, then this would make, if I plug in the numbers, then this would make the function equal to 0. So if I, to find the zeros, we just set the function equal to 0, and now set each factor equal to 0. So x minus 3 equals 0. Okay. 3x plus 1 equals 0, and then x minus 4 equals 0. And now we solve each of these equations separately. So here, x equals 3 if I add 3 to both sides. Here, if I subtract 1, we get 3x equals negative 1, so x equals negative 1/3. And here we add 4, so x equals 4. And so those would be the 3 zeros to this function, okay, or solutions or roots. All those mean the same thing. So again, when factoring polynomials, again, I'll use all the tools that we have. The rational zeros didn't work sometimes. This time they gave us one, so we were really factoring it quadratic after that. But let's try to use all the tools that we have. And again, find zeros, just set those factors equal to 0 when you're done factoring, okay? All right, always remember, math is everywhere.